Last time I made a video, I was talking about derivatives. I took the derivative of x. I took the derivative of x squared, and I took the derivative of x cubed. And I did them all out the long way, and I found out that the derivative of x equals 1. The derivative of x squared was 2x. The derivative of x cubed was 3x squared. You can check for yourself, but I'll tell you that the derivative of x to the fourth is equal to 4x cubed, and it goes on, and what you find is that the rule is x to the n, whatever number, it could be 1, 2, 3, 4, 5, 1,000, is equal to that number times x to the n minus 1. So that's a rule. What I wanted to talk about in this video is, what if you took the derivative of a number, let's say a, times a variable. So in this case, a is a constant. We just don't know what it is. We're just generalizing and saying the letter a in place of an actual number. Here, x is a variable. X changes. So what we do is we set it up the same way as we did in the last video. We say the limit as delta x goes to 0 of, and let's point out that y equals ax, which is a function of x. So what we're saying here is that the limit as delta x goes to 0 of some function, of that function, a times the variable, thing that varies, is going to be that bit, and that's completes that. And we're subtracting from that, we're subtracting the initial condition, which is just ax, and that's over delta x. So since y is a function of x, we can just put this in place of that function of x. That is to say that y is equal to this bit minus this bit, so we can just write that out directly as ax plus delta x, all in parentheses, minus ax all over delta x, and we're taking the limit of that. I'll just keep ... You understand that I'm trying to find the limit in each case. So if I work this out, I distribute the a across, I get ax plus a delta x minus ax all over delta x. I see that ax minus ax cancels out, and the delta x cancels out delta x. All I'm left with is a. So a is what's equal to the derivative in terms of x of ax. And to do another one for you the long way is to say, what is the derivative of ax squared? So again, in this case, y is equal to ax squared, which is a function of x. So we are trying to take the limit as delta x goes to 0 of some function written out as this. So again, if y is a function of f of x, we can just write this out directly. Say it's the limit delta x goes to 0 of a x plus delta x all squared minus ax squared delta x. And expanding this out, we get ax squared plus 2ax delta x plus a delta x squared minus ax squared all over delta x. So we see ax squared minus an ax squared. All we're left with is 2ax delta x plus a delta x squared. So what happens is this delta x cancels this delta x and cancels out one of those delta x's. All we're left with is the limit delta x goes to 0 of 2ax plus a delta x. And if we let delta x go to 0, this is a number times 0, which is 0. So all said and done, 2ax equals the derivative of ax squared. And so the rule in this case is that the derivative in terms of x of a times x to the n is equal to a times n x to the n minus 1. So what this is saying is that the derivative of a times x to the n is the same as taking a times the derivative of x to x to the n. And that's true in all cases. If you have any kind of function of x, a times, we'll call it g of x, where x is just, it could be sine of x plus cosine of x or anything, that's saying that you can take the constant out and multiply it by that function.